Welcome back to our TechBites series. Today, Kane will be introducing our LCOS-SLM range. So Kane, why have you decided to do a talk on the LCOS-SLM today?
The Spatial Light Modulator, or SLM, is a really great and interesting technology from us. As we all know, light can be thought of as a wave and has four fundamental properties: wavelength, amplitude, polarization, and phase. There are lots of different methods available for controlling the wavelength, amplitude, and polarization of light, with filters and polarizers, for example, but it's not so straightforward to control the phase. The LCOS-SLM is a key technology made by Hamamatsu that allows for precise control over that one final property: the phase of light. By using liquid crystals on silicon, or LCOS, the SLM can display computer-generated holograms that spatially modulate the phase across the beam and give you complete freedom to shape the wavefront of the beam.
And where would this beam shaping be useful?
There are lots of different uses for this beam control actually, and it makes the SLM an extremely versatile device. One of the main draws is the overall efficiency. Because the modulation has no effect on the overall power of the beam, the losses are similar to those found in a standard optical mirror, up to 97% efficiency. This is a key detail because it allows you to use the SLM with high peak power lasers without excessive temperature increase, or on the other hand, with extremely low power light, where the high efficiency is extremely useful when you want to lose as few photons as possible. Our SLMs are made specifically for controlling the phase of the light and allow for precise and linear control of the laser beam.
Can you give us some examples of common applications?
So on the high power side, I have to start with laser processing, which really can take full advantage of the high power handling of the SLM. The SLM can be used to correct for aberrations in the system, which can cause unnecessary damage to the material, and also to split the beam, so you can have several laser spots at the same time, which obviously speeds things up a great deal, especially within industrial uses. For 3D printing or additive manufacturing also, particularly where metal is used, the SLM can really come into its own here, again utilising the high power handling with powerful lasers for welding. There are also plenty of uses within super resolution microscopy, where the SLM can be used to give better resolution and signal-to-noise ratio in captured images. They can also be used in light sheet microscopy for all of the same reasons, of course, but in particular for deeper penetration into samples by utilising exotic beam profiles. On the lower power side, there are quantum optics applications, which are often working with a very small number of photons, as well as optical tweezing, where a Bessel beam is used to hold in place or move around molecules. Or holography, where the SLM can be used to display images without using a mask, so the efficiency remains high.
So what can Hamamatsu offer in terms of specifications for the SLM?
We can offer two different SLM models, the X15213 series for research use, and the X15223 series for industrial uses. These both come in SXGA format with 1272 by 1024 pixels and have a wide selection of mirrors available to cover wavelengths from 400 nanometers up to 1550 nanometers. We have aluminum mirrors with a wide wavelength range and around 80% reflectance, dielectric mirrors with around 95% reflectance, and water-cooled models for customers that want to really push the envelope with power handling. In terms of other specifications, the SLM has a high diffraction efficiency, 60 Hz frame rate, and a pixel size of 12.5 microns squared. Our SLMs are also produced entirely in-house, which gives us complete freedom in customization, so we are able to consider any customer requests. We have experience offering custom mirror designs to suit specific wavelength needs, and I'm more than happy to support new developments where something custom would be of interest. We can also combine the SLM with other Hamamatsu products such as cameras, to provide a complete solution.
What can we take away from this talk?
SLMs have an extremely wide range of uses, and there really are so many places where beam shaping can be utilised within research and industry. We touched on some of the most common uses today, but of course there are plenty more I did not mention. We are always keen to have a conversation with anyone interested in using beam shaping in their work, and I encourage them to get in touch with me.